Before we start solving problems with solid geometric figures and looking at compound shapes, let's look at the volume and surface area formulas for 6 of these figures. If we understand these formulas, it'll help us to apply them to compound shapes and problem solve more efficiently. We're looking at surface area, always given with a capital A, and that's the entire surface area of the shape, including the bases, as well as the volume. Surface area will, of course, be in square units and the volume in cube units. We introduce a couple additional letters here, including capital S. Capital S here will mean the lateral surface area, which is the total surface area without counting the bases. This particularly comes in when we start talking about cylinders, so we'll talk about this in more detail after this slide. Let's start with the rectangular solid. The same way that the rectangle is usually labeled with L and W for length and width, here we have a rectangular solid with L, W, and H, H for height. There are 4 sides that have the same length, the same L, 1, 2, 3, 4. 4 sides that have length W, 1, 2, 3, 4. And 4 lengths that are the height, 1, 2, 3, 4. We now need to recognize that we have 6 faces to this. The front face and the back face both have area, length, times height. So the front face has area, length, times height. So does the back face. That happens to be the middle term in the formula. And it's just compressed here, 2 times length times height, but that's really length times height plus length times height. So there is absolutely some algebra that will come into play here. All right, that's 2 of our 6 faces. Now the left-hand side face and the right-hand side face, what area do those have? That's going to be width times height. That's the last one. There are 2 of them. Both have area, width times height, both the left side face and the right side face. And then finally, the top and the bottom face. And then finally, the bottom face and the top face both have area, length times width. There's 2 of them, so there's that portion of our formula. Add them up, you've got the surface area of the entire solid. Again, we want to make sure that we pick up the object and look at it from all sides. So we don't want to discount the base just because it looks like it's sitting on top of a surface. For the volume of a rectangular solid, we simply take the 3 dimensions, length, width, and height, L, W, and H, multiply them together. And that gives us cubic units, which tells us we've done this correctly for the volume. The cube is fairly straightforward. As we had for the square, we've just labeled the sides using S. This could be any letter, could just be X. In any case, every single length has the same value, the value of length S. That means that each face has an area of S squared. So the S squared is the area of each face. In a cube, there are 6 faces, so the area is 6 times S squared. The same way that volume is length times width times height for the rectangular solid, the volume for the cube is 3 lengths, they're just all the same measure, multiplied together. So we express it as S cubed. On this slide, we have the right circular cylinder and the right circular cone. The fact that they're labeled as right cylinder and right cone just means that the height is perpendicular or at a 90-degree angle to the base. So that's true, you can see here, both for the cylinder and for the cone. The fact that they're circular refers to the shape of the bases. The bases in a cylinder are always thought of as the circles at the top and the bottom, whether or not the cylinder is drawn lying on its side or not. Similarly for the cone, when we talk about the base, we're referring to the circle. This is important because we're now going to distinguish between total surface area, that we call just surface area and label with a capital A in our formulas, and the lateral surface area that we label with a capital S. The lateral surface area is the area of the right circular cylinder without the bases. So just the part that here is drawn vertically, discounting the two bases. All right, let's dive in. So the surface area of a right circular cylinder must include the two circles. The area of a circle is pi r squared. Since there are two of them, we find 2 pi r squared given in the formula. So that's the top and the bottom base. How do we get to 2 pi r h for the other part? Well, the 2 pi r h is listed over here as well as the lateral surface area, so we can clearly see even just how the formulas are written, which part of the formula for the total surface area is the lateral portion, must be this. So even if we don't recognize 2 pi r squared as being the area of the bases, the fact that the lateral surface area is the 2 pi r h portion means the 2 pi r squared must be the bases. All right, so what's it composed of? Well, we can think of the part that's wrapped around those circles as a rectangle. So think of taking this right circular cylinder and cutting it along one edge. Once we cut the cylinder and we unravel the portion that's been wrapped around the circle, we're left with a rectangle. This rectangle has height h and width. Well, the width is the same as the circumference of the circle. The circumference of a circle is 2 pi r. So the area of that rectangle, or the lateral surface area, becomes 2 pi r h, which is what we have given here. So essentially, every time we're talking about the lateral surface area of a solid geometric figure, we look at the circumference of the base and multiply that by the height. That will always give us the lateral surface area, with a little bit of tweaking, as we'll see for shapes like our cone. If we're looking for the volume of a solid geometric figure, on the other hand, we're now looking at the area of the base, and we'll multiply that by the height. This will work for prisms as well. Work for lots of objects. So we can see here that the volume is pi r squared, the area of a circle, times h, the height. Well, if you're fairly comfortable with the cylinder, the cone isn't a big deal, at least not in terms of volume. The volume of a cone is 1/3 pi r squared h. So it's once again the base of the object, which is, so the area rather of the base, which is pi r squared, times the height, so we have pi r squared h, but it turns out that a cone takes up 1/3 of the volume of the full cylinder. So because we come to a point, rather than having the top circle have the same area as the bottom circle, which is the case with the cylinder, that's why the cone only takes up 1/3 of the volume. But otherwise, the formula is identical. Now, what about the area? Well, we only have one circle. So for the surface area, we only need to consider the area of a single circle, pi r squared. And in this instance, we once again introduce a new letter. To find the lateral surface area of the right circular cylinder, we calculate pi r s. R is the radius, as it is for every formula on this slide. But s is new. S is not now the side of a cube or the side of a square. S is the slant height. So the slant height is given here. Sometimes we're not given all of this information. Maybe we're only given the radius and the height. If that's the case, then we can use Pythagorean theorem to find the slant height. Alternately, if we're given the radius and the slant height or any other combination, we can find the third side by thinking of the inside of the right circular cone as a right angle triangle. Again, S here, capital S, is the lateral surface area. It's just a reminder that that's the surface area without the base. The last one we'll really take a close look at, is the regular pyramid. We're also going to look at irregular pyramids as part of the examples. So in this case, we need to know what regular means. Regular means the base is a square. If I have an irregular pyramid, the base is probably a rectangle. That's all I need to know about it. For a regular pyramid, the slant height, again given with a lowercase s, is going to be the same on all four sides. For an irregular pyramid, imagine one where we have not a square as a base, but a rectangle. I'm sure you can imagine that the slants are going to be slightly different. The slant for the front and back for what I've drawn here will be the same, as will that for the left and the right. In any case, for this regular pyramid, which again is a right regular pyramid, meaning that the height and the base are perpendicular to each other, for this regular pyramid, here are the generic formulas. We can fill in some of these pieces as well. The volume of a regular pyramid is very similar to that for the cone. For the cone, we had 1/3 pi r squared, where pi r squared is the area of a circle, which is the base of a cone. So we had 1/3 pi r squared times h. That was for the cone. In this case, the base area simply isn't a circle. So we have written here the more generic formula, 1/3 of the base area, and maybe we'll just label it as x. Label the side length as x. In this case, it would be 1/3 x squared times h. So we're left to our own devices here to find the area of the base. Similarly for lateral surface area, again, we're left to our own devices to find the surface area of the base. This just tells us how to work to find the lateral surface area, capital S. We'll take 1/2 of the base perimeter. So this is very similar, if not identical, to the cone, where we looked at the circumference of the circle, 2 pi r, and worked that into our formula. The lateral surface area here actually has the same basics in the formula as we saw for the cone. And once we have a look at this one, we can go back to the formula for the lateral surface area of the cone and see how it's related. So the lateral surface area is half the base perimeter times s. Well, the base perimeter here would just be 4x. If I in fact have a square at the bottom with length x. If I had a rectangle, I'd be worried about finding the perimeter of that rectangle. So back to our 2D objects, our regular surface area. So we'll take 1/2, whatever the perimeter is of the square or the rectangle, depending on our shape, and multiply that by s. S here is, once again, the slant height. How does this compare to the cone that we saw on the previous page? Well, the lateral surface area of the cone was pi r s. How is that the same? Well, let's start with this more generic formula, 1/2 times the base perimeter times s. For a cone, that was going to be 1/2 times the base perimeter. The base is a circle, so the perimeter is the circumference of that circle, or 2 pi r, times the slant height, s. All that's happened then is we've tidied up this formula. 2 divided by 2 is 1, and we're left with pi r s, exactly what's given as the lateral surface area for the cone, the right circular cone. You may want to flip back to that slide and have a look. All right, and then finally the sphere. We can think of this as being created by taking a circle and just rotating it around its perimeter. It's got a volume of 4/3 pi r cubed, and it's because we have this r cubed that we once again end up with cubic units for the volume, and the area is 4 pi r squared. Because the r squared is the only piece with units, that's how we end up with square units for the area of a sphere.